presentation, Hector.
I am ready, chef.
Okay.
So I hope you enjoyed this presentation like I will do. So first things, the name of the capstone is New Method to Identify Illegal Wells, so illegal use of water by using remote sensing data and neural network in Laguna Culeo. Laguna Culeo is a place in Chile. More than 10 years ago, it was a beautiful place. Everyone goes there to swim, um, make a few trips, but right now the lake is dry up. So everything happened in 10 years, and as you can see, from 2009 to 2020, the waters disappeared. So all community believe, so one part of the community believed that it was for the human activity and agriculture, and the other part believed that this was for the climate change, and both some people believe that it was the perfect storm when you use this when you have these two variables acting at the same time. So either way, and no one can use water to irrigate their lawn because it's illegal. So if you do it, you get fined because they try to protect the groundwater levels, and that is because no one can use water. I am going to repeat this again because it's quite important for this presentation, but no one can use water to maintain their grass. So the object for this presentation of this research is extract information from remote sensing data, in this case, the Sentinel-2, and estimate different land index. In that way, we can see which part of the vegetation cover has a good health. And also we are going to use remote sensing data to try to identify which of that green cover are related to grass and in a period of no raining. So that means that if you have a grass and in that period of no raining, the health improve, potentially is because someone is using water to maintain it. So the methodology is quite easy, and basically first we need to set our database, and we need to define what is going to be our no rains event period, that is summertime. Then we need to go to the Sentinel and extract all the information, then estimate the land index, use the remote sensing, and finally make the big conclusion about this and if these tools work to identify people who has been using water in a way that it's illegal right now in Chile, and specifically in Laguna Aculeo. So we have all these variables. We didn't want to estimate only one variable because probably we're going to have biased conclusion. So for this presentation, I'm going to show you only one, but we estimate 6 of them. In that case, when you have all this information, you can make a better conclusion. If you have EVA, EV, or BSI, you can quite sure about what is happening in that vegetation cover. So how this works? So basically, and I'm going to talk only about NDVA, is when this remote sensing captures the reflection, and we can correlate his state with the values that we receive in the satellite. For example, in this case, we only use the near and red band, and that is going to allow us to understand if the vegetation cover is healthy or not. In this case, the NDVA value goes from -1 to 1, and when you have a value around higher than 0.5, it means that you have a healthy vegetation cover. So this is the study area. We have our rainy station, and we are going to go there to see which months we have no rain and this is Laguna Aculeo. And as you can see, it's quite tiny. It's not a huge place, and that is going to be, we're going to process the data to only estimate the values in that specific location. So we went to the raining event. So we went to the raining station, and we saw that from October 2021 to April 2022, there were no rain events. So that means, and as I told you before, probably if one vegetation cover improved their health, it's probably because someone else or for different means has been irrigated that area. So we went to the Sentinel-2, specifically the Copernicus website, and we extract all the bands that we need for estimate the different land index. And we only to make this very clear, we selected the product that has the atmospheric correction. And basically we extracted 16 different raster, and the time lapse between each raster is around 10 or 50 days. So we wanted to achieve 7 goals in this capstone, and you're going to see all of them one by one. So the first one is to create a Python code. This Python code is going to do your work more easily. So in that case, you only need to write the location, and you're going to have all the raster related to that area. So we wrote a code, and that gave us a huge raster, as you can see, and this is the study area. So the next step was to create a routine, a model builder process that is going to analyze the different raster that are located in different folders, and that is going to give you this raster, but clipping the study area, and that is going to decrease our amount of time to process that specific area, and it's going to help to our analysis process. So the goal number three was estimate the last index. So we use a raster calculator, and once again we use a model builder, and we automatically estimate the old raster and with the value for each different land index. And this is very automated. Finally, so the goal number 4 was to train our unsupervised classification. In this case, we use ISO, and probably you can see right here, but we decided arbitrarily that we are going to set 10 different groups, and we decided once again arbitrarily which one of them is correlated with the grass cover. In this case, you have this result that is showing you that it's quite we have a good result, but if you look closer, in some area, the unsupervised classification confuse tree with grass. So we need to improve this in the future work, and probably to do a field work to have a supervised classification, but this is going to be good enough to have an estimate for the potential criminal law. So the goal number 5 was to add all the parcel information. In that case, we can tell to the local authority what is the person who is using the water in a wrong way. And the goal number 6 was to, so we understand which pixel is correlated to grass. So in that case, we can estimate what is the whole area that has grass in Laguna Culeo. Therefore, we can estimate how much water they needed to maintain their health. So this is going to be a huge game changer, because right now we can say that in 6 months, all this basin use this amount of water to maintain or increase the health of this potential grass cover. And by using an if statement, we can select which pixels are more important to us and say to the local authority, go to that specific location because probably you're going to have an infraction over there. We add all this in one ArcGIS web application, and in that case, any people, any local authority can go here and check what is happening in one specific location. And for that, I'm going to play a video, and you're going to understand a little more how to use this.
Hello, and today you're going to learn how to use this interactive map. So for example, the first we have a part where we can add the name of the map. Also, we can add the science article related to this project, for example, the whole documentation. And also, we're going to add a link to fill a legal complaint. This is going to be for all the people that want to see or want to demand a fiscalization. And for example, in this part in the right side, we set or we define a specific part of the area where we can see that this grass area has been watered across this period of no raining. And for how can we sure about this? Because as you can see, the NDVA value, it doesn't change too much until January, and then it started to goes up. And we need to understand this, that this is summertime, so we'll have rain, and also we can add different land index. And in that case, we can compare and see probably this is a potential criminal. Also, if you are looking for a specific part of the area, for example, if you are worried about the soccer field, you can go this and select one specific pixel. For example, this one. And we can have all the values. For example, it's obvious that in this period of time where we have no raining event, for some reason the NDVA goes up, and that means that to maintain the soccer field, someone or probably the local authority use water to maintain their health, and nothing, and they stop since January 2022. And the other thing that I would like to show you, that if you are worried for one specific location and you don't want to know the specific value for one pixel, and you're worried about what is the minimum value or what is the maximum value or what is the average value, in this case I'm going to show you how this is worked. For example, we can select a square over here, and we're going to have all the data related to that square, and we're going to have the average value. That is going to allow us to the local authority to see, hey, maybe it's one pixel who has higher value, or maybe not, or maybe it's the whole area that has a strange NDVA value or something else. Thus, we can do an analysis related to a specific area to make our own conclusion and see if we need a fiscalization or not. And finally, I would like to show you that we have the parcels ID. In that case, the local authority or the government can see, okay, we need to do an inspection for the whole area or not. And the place that we recommend to go that we learned a few slides before. So basically, we recommend that the authority should start with these areas because their value shows an anomaly behavior across this no rain event. And that is all.
Thank you, Hector. And finally, the main conclusion And as you can see, we can use remote sensing data to change the whole way to how to fiscalize or how to be aware about one specific area. We can estimate different land index to make a better conclusion. And finally, we can use neural network methodology to classify different pixel. So in the future, I only want to say that it's going to be necessary to go there and do field work. But for now, I think this is a game changer, and we are going to present this to the local, to the government, to my government, in the next 2 weeks. And that is all. And thank you for all these people, especially because they support me since the beginning. Thank you, Tom Brady.